Hello and welcome to looking at some of the solutions to review questions from Unit 1 in order to get us ready for the first unit test. So the first question we're going to look at is changing out some units. We are given 6 pounds 9 ounces and we want to write that just in terms of ounces. So the first thing we're going to do is we're going to convert that 6 pounds to ounces. One of the things that we're going to need to know is that 1 pound is equivalent to 16 ounces. Okay, so for that 6 pounds, then sometimes people get a little bit confused about when they're doing these conversions, when do they need to multiply and when do they need to divide? And I want you to know when you need to do each one of them, not just make a guess. So one of the ways that we can do this is for the 6 pounds, I'm going to write that, and don't forget to include its units, and I'm going to put it over 1. And we're going to multiply this by something that is called a unit conversion, or sometimes it's called a unit conversion factor. And this will then tell us when and what case do we want to multiply units and which ones do we want to divide them. Now, whatever units I'm trying to get out of, in this case it's the pounds, will go on the diagonal of where they were originally. And where they're going to be originally is always going to be kind of in the numerator. So I'm going to put pounds then on the diagonal or in the denominator of that second fraction I'm going to build. And then in the second fraction, I want to ask myself if I know a relationship between the units that I'm in, which is pounds, and the units that I want to go to, which is ounces. And here's where we're going to use this relationship. There is a relationship between pounds and ounces. Specifically, 1 pound is equivalent to 16 ounces. So to finish this fraction, I'm going to put 1 next to my pound label, which is in the denominator, and then in my numerator, I'm going to record my 16 ounces. Now, why this is called a unit conversion is this is just a really fancy looking one. I technically have the same information both upstairs and downstairs, and in a fraction, if you have the same number both upstairs and downstairs, it simplifies to 1. Multiplying something by 1 doesn't change what it says, but we are going to change how it looks by switching out the units. Now, for this multiplying, then the units that are on the diagonal are going to cancel. Notice that the units that don't cancel are ounces, which is what I want. So now this tells me that to get the number, I'm going to need to multiply. So 6 times 16 is 96, and then my units would be ounces. Now that's just converting out the pounds information on this problem. But the original weight I was given was 6 pounds 9 ounces. So then to get my total ounces, we'll take the 96 ounces that I get from converting out the pounds. I will add to that the 9 additional ounces that I was given. So overall then I would have 105 ounces. A review on that type of question can be found in section 1.9 in your textbook. Looking at the second question, this is an order of operations problem. Additional review on that could be found in section 1.2 in your textbook. Order of operations, which we're going to do grouping symbols first, then exponents, then multiply and divide in order from left to right, then add and subtract in order from left to right. So looking at the problem, 15 minus 9 divided by 3 plus 3 times 4. I don't have any grouping symbols and I don't have any exponents. I do have some multiplying and dividing, so I have some dividing here and I have some multiplying here. Because those operations are separated by this addition sign, if you wanted to, we could attack both of them together. I'm going to carry down the 15 and the minus I haven't used yet, but 9 divided by 3 is 3. I'm going to carry down this plus sign from right here, and then 3 times 4 is 12. So that would be my next line of work, taking care of my division and my multiplication. So now I'm done with all multiplying and dividing. Now I'm going to add or subtract in order from left to right. So I'm just going to do the first two things that I see. So 15 minus 3 is 12. I'll carry down the other pieces of information I haven't used yet, which is that other plus 12. And then I'll do 12 plus 12, which is 24. You should feel comfortable keying this whole thing in your calculator all at once also. Your calculator will follow the order of operations, and you should verify that in your calculator you also get 12. All right, the next question we're looking at is 59.45 is 41% of what number? So this question is relating percents to parts and bases. For additional review on that, we could look in section 1.14. So one of the key things on these types of problems is identifying the part and the base and how that connects to the percent, which is sometimes called the rate. So the 59.45 is our part. The part is usually next to the word is, not always, but that's a pretty good way to maybe get started on a problem like this. The what number is your base or your whole, and those are usually next to the word of. Okay, so again, that's not always going to be the case, but a good rule of thumb. And the 41% is obviously my percent, which is also sometimes called the rate. When we work with it inside of equations, we are going to express this percent in its decimal form. So to convert a percent to a decimal, you're going to move the decimal point left 2 spots and then drop your percent sign. So 41% as a decimal would be 0.41. All right, so there's 2 ways that we can kind of set up the rest of this problem. The one way is sometimes called the percent triangle. Okay, so I'm going to draw a triangle and then cut it with a horizontal line from the top part to the bottom part, and then this bottom part I'm going to put a vertical line splitting it into 2 equal sized pieces. Up here in the top part I'm going to put P for part, and then in the bottom 2 cells I'm going to put a B for the base and then R for the rate. So on this problem, it's my base that is unknown. So what this triangle is telling me is to find my base, I would set up my part, which is 59.45, and I would divide it by, and how I'm seeing my divided by, I'm going to use this bar right here. Okay, so it's my P divided by my R, or my part 59.45 divided by my rate, which is 0.41. So then you can pop that into your calculator and you're going to get your base is 145. Another way to solve this problem is using just maybe a little bit of algebra. So the relationship between these pieces of information is the part is equal to your percent times your base, or maybe in other words, your part is equal to your rate times your base, if you prefer using the word rate as opposed to percent. So on this problem, I know my part, which is 59.45. My rate, or my percent, was 41%, but as a decimal is 0.41. And my base is unknown. So maybe I'll just write capital B for that. So to solve this thing for my base, to get the 0.41 away from it that I'm multiplying by my base, to get it out of there, we would divide it. And if you're going to divide it out from that side, you would divide it out from the other side. So then my base is going to be equivalent to what 59.45 divided by 0.41 is, which is 145. All right, next problem is looking at converting out 168 feet to how many inches. Again, this is in your textbook in 1.9. We need to know that in 1 foot there is 12 inches. And again, if you were getting kind of confused on whether or not you should be multiplying the units or dividing them, especially when the numbers don't work out clean and you might have to have fractions or decimals for your final answer, we can set up those unit conversion factors. So 168 feet, the information that I'm given, I'm going to put over 1, just so I can see it's in the numerator, and I'm going to multiply this by another fraction. The units I'm trying to cancel, which is feet, will go on the diagonal of where it currently is. And then I'm going to ask myself, is there a relationship between feet, which is what I'm in, and inches, which is what I want to go to? And yes, there is. The relationship is 1 foot is 12 inches. So I'm going to put the 1 next to my foot label, and then the 12 inches will go in the numerator. The feet information, because it's on diagonals, will end up canceling each other out. So then we can see, to answer this question, we need to do 168 times 12, which would give me 2,016, and then inches. All right, change a fraction, change the decimal 0.45 to a fraction and express that fraction in simplest form as needed. A review for that would be in 1.10 if you wanted to look at some additional problems or do some additional reading on that. Now, the easiest way to do this is to say this fraction not with the point name, but actually say it properly. So let's say this fraction properly, say this decimal properly. So we need to know our decimal places, right? So whether or not it's tenths, hundredths, thousandths, 10,000ths, and so on. So for this decimal, if I were to say it properly, I would say it as 45 hundredths. All right, so 45 hundredths, if I were to write that as a fraction for what I just said, 45 hundredths would be 45 over 100, right? 45 hundredths. All right, so the other way to do it is to see that there's two numbers after the decimal point right here, so I'm going to have 2 zeros down there, but I think it's also a very important thing that you know how to say decimal numbers properly. And if you can do that, you can get your fraction just by what you have said. Now we're going to simplify this. There is something that goes in both 45 and into 100. It is 5, so I will divide it out from both numbers. 45 divided by 5 is 9, and 100 divided by 5 is 20. Nothing goes into 9 that also goes in 20, so that is my simplified fraction.